चलें यहाँ से अब इसको बस I'll just try and wrap this up quickly कि so we can do past paper questions. तो क्या किया था कि higher potential gains electrons, lower potential loses electrons, and the last thing that we did was that these equilibriums, non-standard electrode potentials, ठीक है, these electrode potentials they can change if you change the equilibrium position. ठीक है, for example एक और एग्जांपल कर लेते हैं. I've got let's say I've got Cl2 plus 2 electrons and it's in equilibrium. It's in equilibrium with 2Cl minus 1. And the E naught for this one, the standard E naught for this one is 1.36 volts. So this one is a gas. This is aqueous science. So what will happen if I do what? If I change the condition, specifically if we increase if we increase so what I'm going to do is increase pressure. According to Lee-Shatler principle, where would the equilibrium shift? किधर जाएगा? Right, left. क्या होता था when you increase pressure?
Right, fewer gases molecules.
ठीक है, so it will favor the side which has fewer gas moles, right? So fewer gas mole side is favored. And that side is obviously the right side. The rule here, if the equilibrium shifts to the right, or it starts to, so it shifts to the right. And if it shifts to the right, then electrons are removed. More electrons are removed or gained. So they get removed from the electrode because the chlorine gaseous molecules, they start gaining electrons. And when they start gaining electrons, the electrode, the platinum electrode, it will have fewer electrons. So it will become more positive. So electrode potential becomes higher. So your electrode potential would increase. So it's going to become higher, and your new potential, your E, will be greater than the E naught. वो जो पुराना वाला था ना, it's not going to be a big difference, but it will just be. So if it was 1.36, now the new potential, it's not going to be 1.36, it's going to be higher. So maybe it's 1.45 volts. Okay, so that's what will happen. Okay, so the idea clear है, simple idea that if the equilibrium, you've got your standard potentials, your non-standard potentials are under non-standard conditions. Under non-standard conditions, the equilibrium is likely to shift either right or left. If it shifts to the left, the reaction produces more electrons, and which is why it's going to become more negative or lower. And if it shifts to the right for any reason, whatever you do, if it shifts to the right, then your potential would be higher because the reaction is going to consume a lot of electrons and your electrode will be electron deficient and it will become higher. ठीक है, ये सारों को clear है ये बात? साथ clear है? Tasneem, Saleh, is this clear?
Yes.
बस ठीक है, इसका जो question होगा ना, that's going to be related to the above, like how do you make a reaction more feasible? ठीक है, let's any reaction more feasible. For example, if I'm talking about the reaction between these two substances, then this is the lower potential, it loses electrons. This is the higher potential relatively, so it gains electrons. तो इसको ज़्यादा feasible किस तरह कर सकते हैं? You have to increase the potential difference. So the lower has to be made even lower and the higher has to be made even higher. So how to increase, यहाँ पे लिख भी देता हूँ. So how to increase E naught cell? And the purpose is to make the reaction more feasible. So make the reaction even more feasible. और ये वाला example कर लेते हैं. So it was Na plus one electron. That was one of the electrodes. Na, the E naught was कितना था? Minus 2.71 volts. The other one was the chlorine plus 2 electrons, 2Cl minus 1 electrode. And that E naught was 1.36 volts. So this is going to gain higher gains and the lower loses, right? The standard E naught cell under standard conditions, it's reduction minus oxidation. So it's 1.36 minus 2.71. क्या value आती है इसकी? मतलब what's 1.4 point क्या था?
4.07.
4.07, ठीक है. So if I were to make it even more feasible, okay, what I need to do is, if I want to make it more feasible, what I'm going to do is I'm going to try and decrease this. And if I want to make it even दोबारा more feasible, तो जो higher है, I want to increase the potential. How can you decrease potential? Force it to shift to the left. And the other one, if I want to make it higher, I need to shift it further to the right. ठीक है, मतलब वही करना है ना कि अगर वो पहले लेफ्ट जा रहा था, लूज कर रहा था, I want to make it lose even more electrons. अगर वो gain कर रहा था, I want to make it gain more electrons, right? So कैसे कर सकते हैं? How do I? Lots of options. ठीक है, if I want to shift it further to the left, what I can do is I can decrease the concentration of Na plus 1 ions. I mean, that's pretty much it. ठीक है, तो automatically left की तरफ shift हो जाएगा और ज़्यादा shift हो जाएगा. The other one, if I want to shift it further to the right, so what I can do is I can either increase pressure, or what I can do is decrease Cl minus 1 as well. That will also further shift it to the right. Concentration. ठीक है, तो ये बात clear है कि वही questions आएंगे. There's nothing really going to be difficult about this. Just remember, shifts to the left, potential decreases. Shifts to the right, potential increases. Is that clear?
Yes.
Yes, sir.
और मतलब यहाँ पे किसी भी रिएक्शन के ऊपर ना जो हमने पहले किए थे, एक तो इक्वेशंस की थी, but any of these reactions, like I've got this entire electrochemical cell. So this was my higher potential. So the higher has to be made if I want to increase the cell potential. The higher has to be made even higher. So even higher कितना होगा? Right की तरफ, further right, उसको right की तरफ. So what I can do is I can increase the H+1 concentration, or I can, in this case, decrease pressure. Decrease pressure करोगे तो more gas is going to get produced. So it's going to shift further to the right. And the lower has to be made even lower. So what I can do is I can further shift to the left, so I can decrease the lead ion concentration. That's something I can do. Okay, is that clear? So
Yes, sir.
अच्छा, तो एक see, just a second, hang हो गया. अच्छा आ गया. अच्छा, so you'll get a number of questions to increase how to increase the potential, cell potential. अच्छा, then ये qualitative है, like this is just guesswork, how to increase the potential. So they're not asking you to do something specific. I mean, increase pressure. So either वो qualitative है कि just I mean, you just have to write a statement. Then sometimes what you would have to do is you have to measure non-standard potential. Exactly. अभी तो वो था ना, तुक्का लगा रहे थे कि ये डिक्रीज हो जाएगा, लोअर हो जाएगा. अब ये नहीं पता कि कितना लोअर होगा. ठीक है, बस we know कि it's going to be lower. So the second thing about this is that you might be asked to measure exactly how much would the potential decrease or how much would the potential increase. तो उसमें कि you have to measure non-standard electrode. Achha, electrode potential. Worry about the electrode potential. You can measure the cell potential automatically. It's the reduction electrode minus the oxidation electrode. So क्योंकि सेल को हम डायरेक्टली तो मेजर नहीं करते ना, so we're only concerned with the electrode values. अच्छा, measure non-standard electrode potential. अच्छा, उसके लिए ना there's an equation and that's known as the Nernst equation. अच्छा, do not try to Google Nernst equation because there are many forms and variants of this equation. तो आप लोगों के लिए there's a very specific variant which is इसको मुझे double check भी करना पड़ेगा. अच्छा, it's E naught plus 0.059 divided by, I think, Z. And it's log of, so it's log of oxidized over reduced. Concentration, square bracket is concentration. So this is going to help you measure the non-standard electrode potential. And I'm going to tell you what each one of these terms stands for. It's, I mean, the first one, E naught, is basically your standard, जो data booklet value है. Mic on है. As a standard data booklet value. Z is the total number of electrons that are involved in the electrode equation. ठीक है, remember हम electrode की value measure करेंगे. The cell potential will automatically get calculated if you know the electrode values. As a number of electrons in equation. Oxidized species is the one that's on the left side. Or the one that is formed after losing electrons. And the reduced one is the one that's on the right side. So this is the one that's formed after gaining electrons. So after gaining electrons. So now, अब इसका example, ठीक है? How would the Nernst equation work? अच्छा, ये log जो है ना, this is log. पता नहीं, no one writes lg, I think. It's always written as L. अच्छा, log. And it's base 10. ठीक है? It's not natural log, it's base 10. So how would you use this equation? We already know what would happen if you have a non-standard electrode potential. So for example, वो Na+1 उठा लेते हैं. The E naught, the data booklet value for this one was minus 2.71 volts. What you're going to do is you've changed the concentration. So now you're under non-standard condition. अच्छा, तो Na+1 की जो concentration है, let's say it's very less, it's 0.01 mole per dm cube. Now the thing was that under standard conditions, Na+1 should have been 1 mole per dm cube. Standard conditions जो होती है ना, that's 25 degrees centigrade, 1 atmosphere pressure, and 1 mole per dm cube if it's a solution. यहाँ पे at the moment it's 0.01 mole per dm cube. तो मुझे पहले तो बताओ कि I've actually decreased the concentration. So where will the equilibrium shift? It's probably going to shift to the left, right? And if the equilibrium shifts to the left, so more electrons are going to get produced. So the electrode potential will decrease. It's going to become more negative because there's going to be more electrons getting produced. So आपका electrode जो होगा, that's going to be way more negative. So the electrode value, the non-standard, not hata the non-standard electrode values are going to be lower. Why? Because more electrons get produced. अब यहाँ तक तो अभी हमने पढ़ा था, ठीक है? We just studied this, ठीक है? So I told you that it will obviously get lower because more electrons got produced. Now what we're going to do is we're going to try and exactly measure what that value is. So how can we exactly measure what that value is? We're going to use the Nernst equation, which is क्या होता है? E is equal to E naught, वो पुराना वाला, ठीक है? That's E naught, which is minus 2.71. Plus के 0.059. Divided by Z, which was the number of electrons in the equation, which in this case is 1. Okay, so that's just 1. So ये 1 आ गया. As a log of oxidized species was the one that's on the left side, formed after losing electrons. So what's the concentration? It's 0.01. Reduced species, the one that's on the right side. Okay. Solid key, the concentration for a solid is always taken as 1. Okay, remember that. ये KC KP में भी यही होता था. Solids, their concentration remains constant. It's always taken as a constant. So I'm just going to make a note over here that okay, concentrations is always taken as 1. So all we have to do is just calculate this. Okay, let me just find out के यहाँ पे calculator है कि नहीं. अच्छा, इसमें log ही नहीं है. Standard. ठीक है, do I have? हाँ ठीक है, log आ गया. अच्छा, I'm going to try and measure this one. Okay, it's per log ले लेते हैं 0.01. So log, sorry, 0.01. So that's coming out to be -2. उसको फिर, this is -2, so multiplied with 0.059. So 0.059, that's -0.118. उसमें फिर I need to add -2.71. So that comes out to be -2.828. So this comes out to be -2. So we predicted that it will be lower, and this is our exact value. Okay, is this clear?
Yes, sir. Yes, sir.
So you just have to remember this Nernst equation. You can measure the non-standard electrode potentials if you know the. Actually, this only works with concentration. I mean, the equation, although it works, there are many different versions of this equation. But the equation that's in your syllabus, that only works with concentration. So it will not be, you will not be asked to do a question where gases are involved. So I can do another one, which is so let's say this one. Okay, I've got Fe3 plus 1 electron in equilibrium with Fe2 plus. The official potential for this is 0.77. So let's say the concentration is इसी concentration ज़्यादा कर देते हैं 1.5 mole per dm cube. And the concentration for the other one is, let's say, 0.04 mole per dm cube. So where would the equilibrium shift? The equilibrium will probably shift to the right. ठीक है, right की तरफ shift करेगा equilibrium. Or what did I tell you? If it shifts to the right, then your new potential, ठीक है, your new potential, your non-standard potential, is going to be higher. ठीक है, ये नहीं पता कि कितना high होगा, लेकिन it's definitely going to be higher. So you're going to have a higher potential, and so that's what you're going to try and find out. What's the new potential? So the new potential is E naught, the old potential, which is 0.77, plus 0.059. 0.059 था, एक second. अच्छा, divide by क्या था? Number of electrons, which कितने थे number of electrons? That's 1. Or फिर log of oxidized species, which is the left one, which is 1.5. Divide by reduced species, which is the right one, which is 0.04. तो ये solve करना है क्या? Can somebody try and solve this? What do you get for this?
.863.
कितना? 0.86. It's coming out to be 0.863 volts. And ठीक है, 0.863 volts. Now, so the point is, as I remember, when you change potentials, the potential value does not change by a huge amount. मतलब वो जो substance है ना, उसकी nature change नहीं हो जाती. It's 0.77, 0.863, not that much of a difference. ठीक है, look at sodium as well. I mean, we already know sodium likes to lose electrons, right? Sodium is always going to be negative. So if you change the concentration, if you change the conditions, the potential might change a little bit. But ये नहीं होगा कि sodium एकदम से you can sort of shift the equilibrium completely to the right, and sodium will start gaining electrons. That's not going to happen. But if you want that to happen, तो उसके लिए you need a very, very extreme conditions, ठीक है? So normally what will happen is that the potential will just slightly change. मतलब वो substance की nature change नहीं हो जाएगी. It's pretty much going to be kind of almost be the same, ठीक है? Just a tiny difference in the value. That's it. So ये बस Nernst equation. You just plug in the values and you solid होगा तो just remember that you put 1. Vice versa, if it's a gas, then you don't need to use the Nernst equation because that's not in your syllabus. So Nernst equation, no one is going to ask you about gases. The other thing about the Nernst equation is that it could be the other way around as well, which is that you might be given the, I mean, उसको reverse पे solve कर लो. You might be given, let's say sodium वाला, ठीक है? I mean, let's do the whole sodium equation in reverse. I mean, the reverse is that there's a non-standard electrode. So the question would be like this. So there's a non-standard sodium ion sodium electrode. with an E naught value of, let's say, minus 2.76. Not E naught, with E equals to minus, instead of minus 2.71, it's actually minus 2.76 volts. So you're supposed to find the concentration, or find sodium ion concentration, square brackets, TK. So the whole question is kind of in reverse, TK. So you're going to use the Nernst equation again. So you already know that the non-standard potential is coming out to be minus 2.76. You know that E is equal to E naught. E naught kya hota tha? Minus 2.71 in the data booklet. Plus 0.059 and then divided by then divide by 1 electron in the equation. Then log of oxidized species, the one that's on the left side, that's Na+1 concentration, which I don't know what it is, over the reduced species, which is the right one, which is sodium in this case. To wo 1 hai, it's a solid. So I just have to solve this, and I'll find the I'll find the Na+1 concentration. So isko solve karna shuru karo, to kya hoga? Minus 2.76 plus 2.71. फिर ये divided by 0.059 होगा. So divided by 0.059 is equal to log of Na+1 concentration. अब अगर तो if you know math, किसी को पता है वैसे log क्या है? Does everyone know what log is? और बाद में बस ये log cancel करना है, ठीक है? So you take the inverse log. तो inverse or anti-log is 10 power x. ठीक है? Just remember कि ये log है, तो उसका जो log inverse होता है, that's 10 power x. So basically it's 10 to the power all of this. So I'm first going to try and calculate all of this. What is all of this? That's here minus 2.76 plus 2.71. Yeah, फिर इसको divide by 0.059. तो ये आ रहा है minus जो भी है 0.0847. So I'm going to write this as 10 power log inverse is 10 power x. So it's कितना था? Minus 0.0847 or minus था 0.0847. 3 significant figures. Okay, that's going to be Na+1 concentration. So we can try and solve that. इसको sorry, पहले वो value डालनी है. क्या था? अच्छा, minus 0.0847. Minus किधर गया?
Yes, sir, I got minus 0.847.
क्या था?
Minus 0.847.
0.0847 नहीं था. 0.059 किया, 0.59 किया.
0.059.
मैं देख लूं, मैंने तो नहीं गलत किया. हाँ ठीक है, मैंने गलत किया. I divided by 0.59. अच्छा, क्या था? 0.847.
Yes.
अच्छा, 1 second. 0.847 minus, और इसको फिर 10 पर x. So I get 0.142. So Na+1 concentration comes out to be 0.142 mole per decimeter cube. अच्छा, anyway, ये मैं फिर से explain कर दूं एक दफा. अच्छा, so the point was that you had you're doing this in reverse. You had a non-standard potential which was given already, minus 2.76. So that was given. So E is equal to E naught plus 0.059 divided by electrons log of oxidized over reduced. Okay, so this was given the standard potential that's given in the data booklet 0.059. You knew the number of electrons in this electrode. That's 1. The only thing that was missing in the equation was Na plus 1. So we took everything on the left side. This came out. The log was cancelled on the right side. Udhar jaake it became log inverse or anti-log. Anti-log is 10 per x. And you got your answer this way. अब ये कोई बता दे who log पढ़ा हुआ है सारों ने कि नहीं पढ़ा हुआ?
So I have used it, but not in detail.
ठीक है, मैं बाकी सालिब, तस्नीम, अरुण, मैं लॉग का बेसिक तो बता दूं कि you're using log. So चलो, लेकिन फिर भी I'll just tell you a basic thing about log. ठीक है, something that would be important if you hadn't. खासकर medical वाले they don't study log. ठीक है. So I'll just, I mean, first thing, ठीक है, remember, chemistry के अंदर you don't, I mean, we're not studying really log, ठीक है, just remember it's a button on your calculator, ठीक है, even if you're confused, this is your Nernst equation, log क्या होगा, that's just going to be a button on your calculator, ठीक है. If you want to take anti-log, then it's 10 per x, ठीक है, remember that. So, like if you take, उधर से log खत्म करना, so you bring it over here, log inverse is basically anti-log. अच्छा, but a brief idea about log. पहले कोई बता दे if you have studied के why is log important? कोई भी बता दे वैसे कोई आइडिया कि log की importance क्या है? तो मैं I'll explain, ठीक है. अच्छा, what log does is that it expresses values. I mean, log base 10, ठीक है, there are many bases. Log base 10 means it expresses, chemistry में अभी फिलहाल it's log base 10. I mean, there's log base 2 as well, there's natural log, etc. everything. मतलब base कुछ भी हो सकती है. अच्छा, so it expresses values base 10 means it expresses values in the powers of 10. For example, if I have a few numbers, like I've got 0.000001, I've got a number which is 0.1, I've got a number which is 10, I've got a number which is 10,000. You may have 100,000 हो गया. And I've got a number which is like really big. So I've got very small numbers, I got very big numbers. ठीक है, now in science you study data आ रहा होता है ना, you study data a lot. ठीक है, I mean that's what you're doing. You make graphs. मतलब कोई भी science जब आप देखते हो ना, there's always a graph involved. ठीक है, जब आप term scientific table होगा या graph होगा, ठीक है, there's always, whenever something is related to science, there's always a table or a graph. Now the problem with, especially with a graph is I've written 5 numbers. It's very hard to actually plot those numbers on the same piece of graph paper. Why? Because scale is, you can't really decide what the scale is. Like one of the numbers is like really big and the other number is like really, really small. So you can't, तो अगर range बहुत ज़्यादा होती है ना, like if there's one number that's very big, one number that's very, very small, you can't really plot them on the same piece of graph paper. क्योंकि अगर if you take पता नहीं क्या है 1 billion है, अगर let's say you take 1 billion as a scale, then you can't even find this number that's too tiny. अच्छा, powers of 10 में क्या होगा? What is this in the powers of 10? Like 10 to the power, what is this thing? कितना होगा? That's 1 2 3 4 5 6 10 power minus 6. ठीक है, ये क्या है? This is 10 power minus 1. ये क्या है? This is 10 power 1. So this is what is meant by base 10. ये क्या है? That's what is this? It's 1 2 3 4 5 है, ठीक है, that's 10 power 5. And this one is 1 2 3 4 5 6 7 8 10 power 8. So what has log done is, if you take log will tell you that this is minus 6, this is minus 1, this is 1, this is 5, and this is 8. So log कर क्या रहा है कि it's very easy to plot these numbers. You got a piece of graph paper, -6, -1, 1, 5, 8. ये सारे एक ही graph paper पे plot हो जाएंगे very easily, ठीक है? So log helps you in managing your data, ठीक है? In the same graph or in the same table, and it just makes it very convenient. यानी बड़े से बड़ा नंबर, छोटे से छोटा नंबर ना, वो 0 से 10 के बीच में फिट हो जाता है, ठीक है? So that is very helpful. That's very manageable. Communicate करना भी आसान है कि किसी को ये बताना कि this is your number. That's like it's very hard to communicate. But tell them that the log number is this thing. It's 8. ठीक है? Just now all your scales, वो earthquake scales, Richter scales, etc. They're all log based. pH scale, that's log. So a lot easier to manage. ठीक है? So that's one thing. And very easy to make graphs, very easy to manipulate data when it is in the form of log. That's one thing. और फिर log से वापस भी जाना है. So remember this thing that if you take log of something, ठीक है, let's say it's और कुछ मैं उसके rules बता देता हूँ. The rules for log are if it's a to the power b and I take log of this, right? Then it's going to be b log a if it's two things getting multiplied. And if I take log of this, then it's going to be log a plus log b. वो इनमें से किसी की भी अगर आपने वो करना है ना कि why is this, so it's simple that if I have 10 squared multiplied by 10 cubed, तो आंसर क्या आएगा? It's going to be 10 to the power 5, right? So what happens is that if numbers are getting multiplied, their powers are actually getting added up. So if numbers are getting multiplied, so log is dealing with the powers, right? So the powers are actually getting multiplied. So it's basically, इसका log क्या होगा? That's going to be 2. This का log क्या होगा? 3 होगा. तो answer क्या होगा? It's going to be 2 plus 3, that's 5, right? So that's the logic behind that, ठीक है? So just remember some identities of this, and always remember कि inverse log, you want to go back. Just a second. अच्छा, बाकी बस ये remember this, that log inverse is basically 10 power x. TS is 10 power x. So if you want to take the anti-log, if you want to take, that's just 10 power x, ठीक है? Whatever the number is, just take. तो इसका मतलब इसका inverse लोगे ना, so it's going to be 10 power minus 6. You take the inverse of, if this is the log and you want to take the inverse, it's 10 power 5. That's it. ठीक है? Clear है ये कि those who haven't studied log, all you have to do is just remember it's a button on your calculator, just press it, ठीक है? और वापस जाना, उसको cancel करना है, inverse लेना, just there's another button on your calculator that's 10 power x. Use that button, ठीक है? Is this clear?
Yes.
Yes.
Achha, now, so that's all about log, and the Nernst equation is not really going to be that difficult. You just have to, well, you just have to memorize this, and you just have to plug in. I mean, इसमें बस गलती है कि just don't plug in the wrong value. The oxide species is the one that's on the left side. The reduced species is the one that's on the right side. Z is the number of electrons. E naught वो पुराना वाला potential, data booklet potential, and you'll get your new potential. Always make sure कि once you do your math, check whether, just यहाँ पे ना पहले I knew कि if the concentration of Na+1 is decreasing, the equilibrium will shift to the left. It's going to produce more electrons and it's going to become more negative. तो बस ख्याल ये रखना है कि आपका आंसर जो है ना, आपकी मतलब उससे मैच करे, ठीक है. अगर obviously if it's not coming out to be more negative, then obviously you did something wrong with the math over here. So that's all about this, ठीक है. अब ये कि there is जो next चीज है, so the next one is there's a thing called electrolysis. I think we use it, electrolysis. So I'll just give you a brief introduction of electrolysis. वो ये कि electrolysis is kind of the opposite of an electrochemical cell. Remember, a cell current produce करता था. There was a reaction that would gain electrons. There was a reaction that would lose electrons. In electrolysis, you've got an external power source, which is a DC supply. And that, so basically, it's not producing current. It's actually consuming current. Okay, so there's an external power source, and that power source helps to drive a reaction. So that leads to a chemical reaction. जहाँ पे cathode होता है ना, वहाँ पे there is reduction. And at your anode, there is oxidation. ठीक है, so this is, अच्छा इसमें ना you can either use this one, वो जो O levels वाला electrolysis है ना, वो भी काम कर जाता है. मतलब इतना डिटेल में जाने की अक्सर जरूरत नहीं पड़ती. तो in electrolysis you've got, first thing, you've got an external power supply. So ये हमारा अच्छा अब इसमें ये कि there's a battery involved. So the battery kind of उसका एक terminal बड़ा होता है and the other terminal is small in size. ठीक है, same चीज O levels. अच्छा, this side is your negative terminal and that side is your positive terminal. The negative battery is sending electrons. So there's अभी reaction शुरू नहीं हुआ. Battery is sending electrons already. ठीक है, the electrons are being sent to the cathode. So the electrons are traveling and they're being sent to the cathode. And on the other side, the battery is, abhi kuch bhi start nahi hua, battery is pulling electrons, theek hai? So the battery already has a potential difference. It's trying to pull electrons. It's trying to gain electrons, theek hai? तो आपका ये वाली side जो है ना, that becomes positive because the electrons are being taken up by the battery, and the other side becomes negatively charged. It's got too many electrons. The battery is sending electrons. तो अब रिजल्ट ये नेगेटिव वाला कैथोड होता है, ठीक है. दिस साइड इज कैथोड and this side is, अच्छा नेगेटिव वाला कैथोड नहीं होता, it's always the side where reduction happens, that's the cathode. इस केस में the negative side is the cathode, but remember technically cathode is the one where reduction happens, anode is the one where oxidation happens. तो ये वाली साइड जो है आपका एनोड है. तो वो काम पहले से चल रहा है, the electrons are already moving. Now what will happen is कि यहाँ पे जो solution होगा ना, if there's someone over here that likes to gain electrons, then the electrons will be gained by that thing. If there's something over here that likes to lose electrons, then the electrons will be lost at this end. For example, अगर NaCl molten होता, ठीक है, so you would have two ions. You got Na+1 which will get attracted to the negative cathode, and you got Cl-1 which will get attracted to the. अच्छा, अब यहाँ पे there is no choice. Cathode पे it will always be reduction. मतलब lose करने का option ही नहीं है. The electrons are coming in. Na+1 has just one option. मतलब यहाँ पे अब वो backward forward वो सब नहीं है. It's only I mean Na+1 उसका अगर electrode भी लिख लो ना तो the potential for this was -2.71. अच्छा, अब मसला है कि बैटरी फोर्स कर रही है because the battery is sending electrons, so the Na+1 ions जबरदस्ती they're going to gain electrons. They've got just one option. So it doesn't really matter कि इसका potential क्या है because it's got no choice. There's no other choice. ठीक है, ये बात clear है कि बैटरी ने forcibly Na+1 को electrons gain करवा दिए. Is this clear?
Yes, sir.
Yes, sir.
अब बस ये लास्ट है कि दूसरी साइड पे क्या होगा कि वो Cl2 plus 2 electrons in equilibrium with Cl-1, and the E naught is 1.36 volts. अच्छा, तो अब वो Cl-1, the battery is taking away electrons, so the Cl-1 is forced to lose electrons. ठीक है, so although we studied that it's the higher potential that gains electrons and the lower potential that loses electrons, लेकिन अब यहाँ पे होगा कि वो वाली बात अभी आएगी, वो अगली क्लास में आएगी. लेकिन पहली चीज ये क्लियर कर लो कि कैथोड पे there's only one option, which is reduction. Cathode पे whoever's there, it's going to gain electrons. No matter what the potential is, negative or positive, or it's going to gain electrons. It's got no other choice. Anode पे, it's got no other choice. It's going to lose electrons. Doesn't really matter if the potential is higher or lower. It's always going to lose electrons. तो इसकी डिटेल जो है फिर अगली क्लास में कल करते हैं. But just remember that it's exactly the opposite of an electrochemical cell. The electrons are already running around because of the battery. ठीक है, reaction हो या ना हो, electrons की movement is going to happen in this way. And that will force a reaction. Gain of electrons on one side, loss of electrons on the other side. So it's exactly the opposite. उसमें पिछले में था कि reaction होता था, उससे फिर electrons flow करते थे. This is exactly the opposite. So ठीक है, ये फिर अब next class में ना इसकी details वगैरह we'll study those. ठीक है. So कोई question तो नहीं किसी का?
No questions, sir.
चले. Okay then.
Thank you, sir. Allah Hafiz.
Allah Hafiz.
Allah Hafiz.